everyone. Myself, Mrs.S.Nusrath Najeeba, Assistant Professor, Department of Computer Science, SF, the Standard 5 Works, Rajaratnam College for Women, Sivahasi. In this video lesson, we are going to see about the graph in data structure. These are the learning objectives of this video. First of all, we have to see the introduction of what is a graph and its types. After that, we will see how we are representing graph in data structures. Then what is DFS and BFS. Let us start with the introduction. First of all, while talking about data structure, we are having two types of data structure, that is the linear and the non-linear data structure. Graph data structure, it is a non-linear data structure consisting of vertices and edges. It is useful in fields such as social network analysis, recommendation systems and computer networks. Graph, this contains vertices and edges. The vertices are sometimes referred to as nodes and the edges are lines or arcs that contain any two nodes in the graph. More formally, a graph is composed of a set of vertices that is represented as V and set of edges that is represented as E. Overall, the graph is denoted by G of E, V. Okay. Here are the types of graph. The first type is the null graph. A graph is known as null graph if there are no edges in the graph. In this example, we are seeing this graph has no edges, that is the lines. This graph doesn't contain any lines. That's why it's called as null graph. The second type is trivial graph. Trivial graph refers to the graph that has only one vertex. It is also the smallest graph that can be drawn. The third type is the undirected graph. The undirected is a graph in which edges do not have any direction, that is the nodes are unordered pairs in the definition of every edge. The fourth type is the directed graph. A graph is said to be directed when its edges has direction, that is the nodes are ordered pairs in the definition of every edge. The next fifth type is the connected graph. Connected graph is a graph in which from one node we can visit any other node in the graph. The sixth type is the disconnected graph. In this graph, there is at least one node is not reachable from a node. The seventh type is a cycle graph. Cycle graph, in the name itself, it refers that the graph has a cycle in itself. The minimum value of degree of each vertex is 2. Eighth one is cyclic graph. There is a difference between cycle and cyclic. A graph is said to be cyclic when it contains at least one cycle. Next type is the directed acyclic graph. A directed acyclic graph that contains any cycle, which it refers to that the graph has directions but it doesn't create any cycle. The last type is bipartite graph. A graph in which vertex can be divided into two sets such that vertex in each set does not contain any edge between them. Okay. While seeing the structure of a graph, it resembles a tree, but there are differences between a tree and a graph. Tree is a restricted type of graph data structure, just with some more rules. Every tree will always be a graph, but not all graphs will be trees. Linked list, trees and heaps are all special cases of graphs. Okay. while representing graph, we are having two types. The first one is the adjacency matrix, the second one is the adjacency list. Okay. This is the adjacency matrix representation. In this matrix representation, we can see that first 0 to 0. In that 0 to 0, there is no edge. So, we representing this as 0. Then, while moving to 0 to node 0 to 1. In node 0 to 1, there is an edge. That is why we are given 1 in the matrix. This is the representation of a This is the representation of a graph in the matrix. Then we can use linked list to represent the graph. Graph operations. While talking about graph operations, we are having two main operations. That is, first one is the depth first search, which is also referred as DFS. The second one is the breadth first search, which is also referred as BFS. First of all, we see about the depth first search, that is DFS. Okay. DFS for a graph is similar to the depth first traversal of a tree. Like trees, we traverse all adjacent one by one. When we traverse an adjacent, we finish traversal of all vertices reachable through the adjacent completely. After we finish one adjacent and it's reachable, we go to the next adjacent and finish all reachable through next and continue this way. Similar to trees, where we first completely traverse the left subtree and then go to the right subtree. The only catch here is that unlike trees, graphs may contain cycles. A node may be visited twice. To avoid processing a node more than once, we use a Boolean visited array. This is the working for a This is the DFS search for a graph. The algorithm starts from a given source and explores all reachable vertices from the given source. It is similar to pre-ordered tree traversal, where we first visit the road, then record for its children. In a graph, there may be loops. So, we can use an extra visited array to make sure that we do not process a vertex again. Let us understand the working of depth first search with the help of the following illustration for the source as 0. This is the step 1. Initially, we are having the stack and the visited arrays as empty. Next, we visit 0 and put its adjacent node which are not visited yet into the stack. Then, we visit node 1 which is at the top of the stack. So, visit node 1 and pop it from the stack and pull all of its adjacent node which are not visited in the stack. Then node 2 is the top of the stack. So, visit node 2 and pop it from the stack, pull all of its adjacent node which are not visited, that is 3 and 4 in the stack. Then node number 4 is the top of the stack. So, visit node 4 and pop it from the stack and pull all of its adjacent nodes which are not visited in the stack. Now, the top of the stack is 3. So, 3. So, visit node number 3 and pop it from the stack and pull off its and put all of its adjacent node which are not visited in the stack. Okay. Now we can see that the stack is empty, which refers to that we visited all the nodes in the graph. This is the depth first search for a graph. Then we are going to see about the breadth first search. It is a fundamental graph traversal algorithm. It begins with a node, then first traverses all its adjacent. Once all adjacent are visited, then their adjacent are traversed. This is different from DFS in a way that closest vertices are visited before others. We mainly traverse vertices level by level. A lot of popular graph algorithms like Dijistra's shortest path, Khan's algorithm and Prim's algorithm are based on BFS. BFS itself can be used to detect cycle in a directed and undirected graph, find shortest path in an unweighted graph and many more problems. Okay. To find a BFS from a given source, the algorithm starts from a given source and explores all reachable vertices from the given source. It is similar to the breadth first traversal of a tree. Like tree, we begin with a given source and traverse vertices level by level using a queue data structure. The only catch here is that unlike trees, graphs may contain cycles, so we may come to the same node again. To avoid processing a node more than once, we can use a Boolean visited array. In this, we are having two main steps. The first one is initialization, second one is the termination. In initialization, we are enqueue the given source vertex into a queue and mark it as visited. In this, we are having another step called exploration. While the queue is empty or not, this is a step for exploration. If it is not empty, then dequeue a node from the queue unvisited. For each unvisited neighbor of the dequeued node, enqueue the neighbor into the queue. Mark the neighbor as visited. In the process of termination, we have to repeat step 2 until the queue is empty. This algorithm ensures that all nodes in the graph are visited in a breadth first manner starting from the starting node. Here is an example. In this, we can see initially the queue and the visited array both are empty. Now we are pushing node 0 into the queue and mark it as visited. Then remove node 0 from the front of the queue and visit the unvisited neighbors and push them into queue. The unvisited neighbors here are 1 and 2. Now remove 1 from the front of the queue and visited the unvisited neighbors of node 1, that is 3, and push them into queue. Now remove node 2 from the front of the queue and visit its unvisited neighbor, that is 4, and push them into the queue. Now remove node 3 from the front of the queue and visit the unvisited neighbor. Here we can see that there is no unvisited neighbor, so there is no need to push anything. Now the front of the queue has 4. So visit the 4 and check whether it has any unvisited neighbor or not. Here we can see that there is no unvisited neighbor, so the breadth first search is completed here. I hope from this video you can understand what is a graph data structure. Thank you for watching the video.